series Programming in C. In this module of the series, we are going to learn about the various operations of a variable through pointer. In the previous session, we have learned the way how the pointers can be declared, initialized and accessed with an address operator. This session, we will look into the way that how various operations of a variable can be done through pointers, and again how a pointer can point to another pointer. So, this module covers the declaration of pointers, memory address, details of memory address and how actually it is being represented and organized, address operator ampersand, then initialization of pointers in C, then how actually the value of the pointers or value of the variables are accessed through pointers, and we will see various examples related to handling the pointers, especially with the memory. Now, pointer declaration in C, we have already learnt that pointers are the variables which can store the address of another variable. So, pointers in C are very crucial for direct memory manipulation, serving as variables that store memory addresses. So, they enable referencing specific memory location, enhancing the programming flexibility. So, this will guide into dwelling, declaring and initializing pointers with address of other variables, so that the fundamental role of C programming is being satisfied with the help of pointers. So, in the C programming language, every variable we define is allocated a specific memory location. To access this particular memory location, we will be using the address operator called ampersand. We will use a symbol ampersand to denote the address of a particular variable. Say for example, if there is a variable named VAR in our program, then the memory address of the variable is represented to be ampersand VAR. So, this memory address we will be using in the standard functions like scanf, where we need to read some user's input and store it in some memory location. So, at that particular time also we will be using the symbol ampersand to denote that it has to be put it into a memory location using the function scanf, right. I want all of you to focus on this and learn the relationship between computer address and variable, right. So, what is an address? Generally, if we are going to talk about the real world houses and homes, okay, every house is identified uniquely using an address. The address will be having the street name and the area name and region and district name and pin codes if we are going to use it in a unique way. Likewise, the computer's memory will also be having an address to uniquely identify the values. The address depends on the size of the architecture of the machine. If we are going to use a 32-bit architecture machine, the size will be of 32 bits. If we are going to use a 64-bit, then the size will be of 64-bit. So, generally the address will be represented using a hexadecimal notation. So, here we can see an example 9 and ending up with all zeros represents an address, right. So, here we can see 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9 they will not be 10, because since it is an hexadecimal notation, after 9 it will start with A, B, C, D, E, F, and then again it will be incremented by 1, it starts with 1, 0, 1, 1 likewise. Okay. Now, I am trying to store the first variable sum, which is of 4 bytes. Actually, according to this example, we are assuming that each location is represented using 1 byte. So, in this case, if we are declaring an integer type variable for with the name sum, which occupies 4 bytes, the value which is stored in the particular 4 bytes will be of all zeros ending up with FF. So, FF stands for if you convert it to decimal value, it will be 255. So, the sum value will be 255. what is the value which I am trying to store. So, if you can see that it is stored as 000000FF. Okay, that is how in the memory the values are being stored. Now, age, we are using the short int type, data type is short int. So, if the data type is short int, it occupies 2 bytes. So, 2 byte data will be represented using 2 address locations FF, right. Then I am going to declare a double type variable. A double type variable occupies 8 bytes. Okay. The name of the variable is average. So, what happens if it occupies 8 bytes, there is a need of 8 memory locations for double type, right. So, the double type range, it varies from 4.45 to 308 base 10, right. And if you see, and then I am declaring an integer pointer in my code. So, what happens? An integer pointer will be of 4 bytes. Okay. So, since it is of 32-bit architecture, so 4 into 8 will be 32 bits. Since the architecture is of 32 bits, the pointer size is of 4 bytes. So, if the pointer size is 4 bytes, we need 4 memory locations for the variable ptr sum. Okay. So, this is how the memory is being organized and what is the need of address and its significance. Now, supposing if I want to access the variable average, the address of the variable average starts from 6. So, this will be the address of the variable average, starting address of the variable average. Similarly, when I want to represent age, the address of age will be this. Okay. So, when I am trying to store the address of sum, okay. So, or when I am trying to refer or try to access the value of sum, okay. So, what I need to do? I need to first get the address of sum, and then I need to make the pointer move to that particular address to fetch the value which is stored in that memory locations, in those memory locations, 4 bytes, right. So, this is the way that actually we try to use the address, right. Supposing when I am using a pointer type variable. So, pointer type variable ptr sum I am using, which points to an integer data type, right. It may be sum. So, what I do, ptr sum is being assigned with the address of sum, right. So, what happens, ptr sum will be assigned with the address of sum, which is 9, starting with 9 and all zeros. Okay. So, what happens when I am trying to look for the value which is stored in the variable sum, I need not go check what is the address of sum and then fetch its value. Instead, if I have the address of sum with me, so directly I can go to that address and I can fetch whatever the value which is stored in that particular address location. So, this is what is the advantage and strength of using pointers. So, the address operator ampersand will help us store the address of a particular variable. So, as given in this example, variable A is represented with the address 1000, variable Q is represented with 1004 and variable M is represented with the value 1012. We should know how to make use of the pointer and how to do various operations using the pointers. Okay. So, generally how to declare the pointer? The first step is you need to declare a variable of any type. The data type can be integer, float or char, whatever it be, and the value 5 is being stored in a particular memory location 1010. Then I am declaring a pointer type variable p. Now, while declaring the pointer type variable p, there is no value in it, right. But when we are trying to make the pointer variable point to a particular variable var, we have already the address 1010. So, value of 1010 will be put into the pointer variable, that will be pointing to the variable VAR. Okay. So, using this location 1010, we will be able to make the pointer point to the corresponding 1010 location, where actually the value of the particular variable is being stored. However, the address of the pointer variable will be another address, that will be a different address. So, we are actually creating the pointer variable and whose address is 2456, right. So, the syntax of creating the pointer variable is going to be data type asterisk pointer variable name, right. How to initialize a pointer in C? So, when we create pointers in C, it does not automatically point to any specific memory location. We are supposed to explicitly assign an address to the pointer variable. Without using or without having the ampersand operators support, we will not be able to store the address onto a particular pointer type variable. Failing that will fail the initialization of pointers. So, here we can see we can also declare a function pointer. So, how we can declare a function pointer? We can just include the asterisk with the name of the function. So, this actually points to the address of the function that can also be stored in a pointer type variable. Okay. There are two ways of initializing the pointer type value variable in C. The first one will be we can initialize a pointer variable by pointing it to an address of another variable. This is method 1, and method 2 is going to be declaring a pointer variable which will point to another pointer variable. So, this is method 2. So, what actually happens? Ampersand is the reference operator, which means it is used to get the memory location of a variable. So, A is an integer variable, and by making it as ampersand A, we are making the address or location of the particular variable A being pointed by the pointer variable ptr1. This is the first method. So, what we do in method 1? We make use of the reference pointer ampersand to get the memory address of a variable, and it is also called as address of operator. Yes. So, what we do? We are trying to declare the variable with and assign the value 5, that is what is being done here, and we are defining the pointer variable and assigning the address of A to the pointer variable. So, this is method 1. This is the usual method we do, right. Method 2 is, let us consider the case when we want another pointer to point to the same variable. Okay. So, then what we do as a first step, we do the same process. This first and second step are similar to method 1. In method 2, we are adding one more step, int asterisk ptr equal to ptr1. It means that we are making the pointer 1 which has the address 1010 to point to the variable's value 5, right. So, 1010 will be stored in the ptr1's value. Now, ptr1's value can even be addressed through ptr2's value. ptr2 will also be able to store the same value 1010, and it can also have access to the same value of the variable. So, let us take an example, int var equal to 10. So, value 10 is assigned to var1. Now, the second step is ptr equal to ampersand var. So, what happens? The address of var is now stored onto ptr, then asterisk ptr equal to 20. Now, we are trying to make the value which is stored in var be replaced with 20, and in asterisk asterisk ptr we are using double asterisk. So, here you have to notice that we are using a double dereferencing operator, in the sense that when I say star ptr, it refers to the value it is pointing to, ptr is pointing to, and when I say asterisk asterisk ptr, we are trying to refer to the value which is pointed by another pointer. So, here we are making that to be 30. So, what happens? 20 is now replaced to be 30. So, 10 is replaced with 20, 20 is now replaced with 30. Anyway, the location is going to be the same, but the same location is accessed with 3 variables. What are the variables? VAR is one variable name, PTR is pointer variable through which we are trying to access the same location, we are trying to modify its value, and asterisk PTR is also referring to the same location and we are trying to update the value. But we have to be very careful on usage of pointers that since we are trying to directly access the memory, whatever the changes we do with the memory locations value will always be updated, will always get modified. Okay. We will lose the original value because we are making the pointer to point to the memory location directly, right. Now, how to access a pointer in C? You can access both the address in memory where the pointer points to and the value it points to. So, to do this, first we have to understand the dereferencing operator asterisk, how it works. The process of getting a value from a memory address pointed by a pointer, that is what is called dereferencing. So, what we are doing? We are using the asterisk operator to refer to the location of the pointer, and from that we are trying to retrieve the value. So, which is called dereferencing. So, asterisk operator is actually used for two purposes. One is to declare a pointer, the other as the dereferencing operator. Now, supposing when I am using the printf statement and I am trying to print the pointer's value using the format specifier %p, then we will be able to get the address displayed. So, for example, here we are trying to store a variable a with value 5 and I am trying to store its address. The address of a is now being stored in PTR1. Now, PTR1 we are trying to display the value of PTR1 which is actually the address. So, the address 1010 is now displayed and we want to refer to the value which is stored in that location. So, for that we are again supposed to use a dereferencing operator asterisk. So, this refers to the value which is stored in the particular memory location. So, 1010 is a memory location, 5 is the value stored in that location. Okay. So, there is a difference between accessing the pointer directly and accessing the value stored in the pointer. When you want to access a pointer directly, it is done by just the pointer variable's name. If you want to access a value stored in that pointer, we need to use the asterisk operator along with the pointer variable's name. Okay. So, the difference is given here with the figure. As a first step, we assign the value 5, memory address is 1010, value is 5. Then we are trying to make the PTR1 to access the value 5. So, what happens? PTR1's value is now 1010, right. Now, we are trying to print the value stored in PTR1. So, what happens? We are now trying to access the PTR1 pointer variable. The pointer variable has the value 1010, then we are pointing to the location 1010 from which we are retrieving the value 5. Okay. So, this process is actually called dereferencing and the operator is dereference operator asterisk. Now, assume that we have created the pointer variable and we are trying to make the variable address to be pointed to that pointer variable. Now, will we be able to change the value using pointer? Yes, of course, we will be able to do. So, here let us take an example of a variable number whose value is 42 and the address of number is now being stored in PTR, asterisk PTR, right. Now, the value of PTR is now changed to 99, right. But here you can see if you are trying to display the value would have been modified. As I have already told that since we are having direct access to the memory, whatever the changes we do with the memory location will be reflected, will be changed, will be modified, right. So, we will see as a whole a program to create, initialize and access a pointer. So, we will take the same example of having the same name for the variable as a equal to 5 and int asterisk ptr pointer variable, initializing the pointer variable, and we are trying to assign the address of variable a to the pointer variable, and if we are declaring the value of a will be 5, right. So, here 5 will be displayed. Then address of a, so address of a is going to be 1010 as the example which we have seen earlier, or else there will be the address displayed like this, right. And value of ptr1, value which is stored in ptr1 will be pointing to the value which is stored by the address of a, which is again 5, value will be 5. So, the address of ptr1 will be the same address of a, right, because we are making both ptr1 and a to point to the same location. The address of the location is 0x7ffd75fe33dc and the value stored here is 5. So, both ptr1 and a points to the same location. So, what we do using ptr1, if we are trying to change the value, the same value will be updated. After that, when we are trying to access the value using the variable name a, also the value would have been updated or changed. Then how do we access the address of a variable? That could be done using the ampersand operator. So, we have already seen the implementation using address operator, right. Then there are 3 types of pointers: near pointer, far pointer and huge pointer. Near pointer accesses memory within the current segment only. So, actually the memory will be segmented. So, 64 KB may be the usual segmentation size. So, this typically uses a 16-bit address. So, if the address which we are trying to address if it is in the same current segment, then the pointer is called near pointer. It will not be able to reach memory outside that segment. Inside that segment only we will have access to. And far pointer stores memory using 2 16-bit values called segment and offset, in the sense that which particular segment, in that particular segment what is the particular address. Okay. So, we need 2 parameters here to specify the address if it has more number of segments. Supposing if I have 5 segments, I want to address a particular address in 4th segment. Okay. So, in the 4th segment, what is the offset? So, we are supposed to give 2 16-bit values in case if we are referencing or if we are accessing a particular physical address, then it is called far pointer. Then huge pointer, it is also similar to far pointer, but the segment and offset can keep changing, allowing the movement across segments. We can even move from one segment to the other. In that particular segment, what is the offset? So, we can have movement across the segment using huge pointer, right. So, summarizing on this particular session, we have learned the significance of pointers in C language, how the pointers will help us in accessing the memory directly, and what is the use of the operator ampersand. And we have also seen the ways of initializing the pointer. There were 2 methods. One is by directly assigning the address of a variable. The other is by creating a pointer variable, and that pointer variable can be an input to another pointer variable. Also, we have seen various addressing methods. We have learnt the organization of memory and types of pointers like near pointer, far pointer and huge pointer in memory mode. Thank you so much for listening to the session and understanding.